Good day, fellows. Seto is back. Then, we are still going to continue with the concept of isotopes. Isotopes. We said last the term isotopes implies with the same atom with same atomic number but different atomic mass. Atomic mass. Let me take the previous example. Last time I gave you chlorine with an atomic number of 17 with 35. I also gave you 1737. Then we said that this one, it had the abundance of 75,5. Then last time we said this one, it had 24.5% abundance. You see? Then I asked you to determine what the average or the relative atomic mass whenever they have given you what the abundance of each or the percentages of each. You see? Firstly, what I'm going to do is I want us to add these two numbers. Let us try to add these two numbers. Don't forget, this thing is a percentage. You see? Don't forget that this thing is a percentage. Somehow, it is going to be like this: 75,55 plus 0,245. You see? If I add these two numbers, let's see what do we get. 0,55 plus 0,45. We get the total of 1. You see? Then, how then are we going to answer this question? I wanted you to see that if we add these two numbers, we get the total of 1. Let's say now, if they don't give us these two numbers now, the abundance of each. Let's say they say for this one is X, for this one is Y. They want us to figure out the abundance of each. Then how are we going to do that? If now let's say they want us to calculate the abundance of each. Let's say they say, what is the abundance of each atom if the average or the relative atomic mass is 5,4, let's say 9 How are you going to determine the abundance of each? Firstly, we must consider the very same thing which I showed you just now, to say if I add the percentage of this and this, at the end of the day, I must get the total of 1. You see? From there, I'll just come back to this thing. But firstly, let me do this one. We know that we have the average or the relative atomic mass. Some will say the relative atomic mass, then equate it to what? We take our atomic mass now of each, which is 35 for this one, put x, plus we have 37 for this one, we put y. Then they also gave us the relative, so the average there, which is 35,49 equals to 35x plus 37y. See? Then what I'm going to do now is I'm going to say, since just now I showed you that if I add the percentage of this and this, I must get the total of 1. We're then going to take this y to the other side, which is going to be like this. Where you see your x, we want to substitute 1 minus y. We must make sure by all means we have the same variable throughout. Where we see x, we substitute this, then it's going to be 35, 1 minus, where we see x, y, c, I hope you can see, then k, yeah, plus 37y. Then this side we have 35,45. Let us distribute everything. We are going to get 35 minus 35y plus 37y. This side we have 35,49. See? Then at this point we only have one variable, which is y. Let us try to solve that variable by taking 35 to the left hand side. If we take 35 to the left hand side, we are going to have 35,49 minus 35. This side will be remaining with 35y plus 37y. At this point, I'm going to use a calculator. Negative 35 plus 37, we get 2. We get 2y. Then let me take 35,49, subtract it to 35. Then for this one, I get 0,49. Okay, if I divide throughout by 2, then our y is going to be, say, divide by 2, we are going to get 0,245. This is our y. For us to get our x, do you see this equation? Do you see this equation? Where we see y, we are going to substitute this number. Then it's going to be x, which is equals to 1 minus 0,245. If we take our calculator, we have x, 1 minus 0,245. We are going to get 0,755. You see? For x now, for x, we are going to have, now 0,755. For y, we are going to have 0,245. 0.245. You see? You see? Then let us multiply each by 100. If I multiply this thing by 100, I'm going to get 75.5%. Then this one, I'm going to get 24.5%. You see? This was just the reverse question of the previous one. You must do by all means that you understand this one, because it looks much tricky compared to the first one. I thank you and enjoy.